So question 21 onwards. Information about some of the silver compound is shown in the table. As you can see, like compound silver carbonate, silver chloride, silver nitrate, and silver oxide. So different compounds of silver are shown here. Right, which equation shows a reaction which cannot be used to make a silver salt? So which reaction we cannot use to make a silver salt? Because when the salt is formed, we should remove that salt by either filtration or crystallization. So when we add aqueous silver nitrate with hydrochloric acid, it will form silver chloride. So this will produce silver chloride AgCl, which is solid. So we can remove, because when we mix the two solutions, a solid is formed. So this solid is called precipitate, and we can remove this precipitate by filtration. So we can use this method to obtain silver chloride. Then if we mix silver oxide, metal oxide plus acid, give salt and water, silver nitrate, salt is there. So this salt, this can also be used because metal oxide reacted with acid gives salt and water. So we can obtain the salt by crystallization. Silver carbonate react with nitric acid, gives silver nitrate plus water plus carbon dioxide. So we can also use this method. But silver plus hydrochloric acid, if you remember the reactivity series, what is the reactivity series? We have potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, mercury, silver, gold, and platinum. So elements which are above lead or above, they can react with dilute acids. And in the lab, we use dilute acids, so they can react with dilute acid. But copper, mercury, silver, so there is no reaction with acid. They don't react with acid. So if the metal is mixed with acid, actually there will be no reaction, as well as this technique, why it is not suitable, because we are adding a solid, and as a result solid is produced, so it will be difficult to separate the two solids from each other. That's why D is a technique which cannot be used to prepare a silver salt. So the main reason is, number one, it does not react with acid. Number two, even if you use a concentrated acid to react, but we cannot separate the two solids from each other. In question 22, what is not a property of group 1? Group 1 are alkali metals. They are highly reactive. So they are soft and can be cut by a knife. That's true. This is a property of group 1. They react when exposed to oxygen. They are highly reactive metal, tend to lose electron easily. They produce acidic solution. That is wrong. They don't produce acidic solution. They produce alkaline solution. Like if we have lithium, when we add to water, so it will produce lithium hydroxide plus hydrogen. If we have sodium, we add to water, it will produce sodium hydroxide NaOH plus hydrogen. So alkali metal react with water, form metal hydroxide or a base or alkali. So the pH of the solution will be more than 7, or it will be alkaline solution, not an acidic. And they react rapidly with water to produce hydrogen. That's also true. So C is the right answer. That is not the property of group 1. Group 1 are known as alkali metals because they tend to form alkaline solution, not acidic. 4 substances are tested. P, Q, R and S, the 4 substances are there. So the question is, what are P, Q, R and S? So from these tests, we have to identify what are P, Q, R and S. When we add acid, it gives off, because a gas is given off which pops with a lighted splint. So a substance which react with acid because pops with high Lighter splint means hydrogen gas is given off. So remember, whenever plus acid, metal plus acid will give salt and hydrogen. And hydrogen gas pops with a lighted splint. So this gives an idea that P is a metal. So either A can be an answer, B can be an answer, or C. But it cannot be D, because if carbonate was there, it gives carbon dioxide. So first, P gives an idea P is a metal. So the options in which P is a metal is either A, B, or C. Then for Q, when we add acid, gas is given off which turn lime water milky. So it means carbon dioxide gas is given off. So what is compound Q? Compound Q is a carbonate, metal carbonate. Because whenever metal carbonate is mixed with acid, what it will give? It will give salt, it will give water, and it will give carbon dioxide, which will turn lime water milky. So Q is actually metal carbonate. Then what about R? So Q is metal carbonate. So either now B cannot be an answer, because in B it is ammonium salt. So either A will be answer or C. Then when we add hydrochloric acid, there is no reaction. But when we add sodium hydroxide, warm with sodium hydroxide, ammonia gas is given off. So this is a characteristic of the ammonium salt. Ammonium salt, when they react or mix with sodium hydroxide or alkali, remember, whenever we have ammonium salts and we add an alkali, as a result, one of the product is ammonia gas, and which is turning the red litmus paper blue. So ammonia gas is released, and what it confirm? What about R? R is, it means it is ammonium salt. Ammonium salt means salt which is having NH4. So the salt which is having NH4, it cannot be now C, it is actually A, because P is metal magnesium because it gives off hydrogen with acid. Q is metal carbonate because it gives carbon dioxide, and R is a ammonium salt because with sodium hydroxide it gives off ammonia gas. And the last one, that is sodium chloride, does not react with acid or alkali. So these are the characteristic reactions of acid and alkali. Acid plus metal give hydrogen, salt and hydrogen. Acid plus metal carbonate gives salt, water, and carbon dioxide. Alkali plus ammonium salt give ammonia gas. So we can identify that ammonium ion is present. In question 24, which statement about the transition element and their compound is correct? All transition element have oxidation state of +2. That's wrong. They don't have fixed oxidation state. They have variable oxidation state. So we cannot say they all have +2 oxidation. Aqueous solution of salts of transition elements are generally colored. That is true, because they tend to form colored compound. So B is the right answer. Why not C or D? The transition element changes from metal to non-metal. That's wrong. All of them are metals. That's why we call transition metal or transition elements. They all are metals. Transition element can act as a catalyst, where their compounds cannot. That is wrong. Both transition element and their compound can act as a catalyst. Impure iron from the blast furnace is converted into steel. Which statement? So this is a conversion of iron. So iron which we extract from the blast furnace, that is not a pure iron. It contains impurities such as carbon is there, and it also contains silicon 4 oxide. So these are the impurities which are present in the impure iron which we extract from the blast furnace. So which statement? So what happened basically, we had oxygen. When we blow oxygen, oxygen reacted with carbon, as a result produced carbon dioxide. And then we had calcium oxide. So calcium oxide react with silicon 4 oxide. So silicon 4 oxide react with metal oxide, calcium oxide, which will form calcium silicate or slag. So which statement about the process is correct? Acidic oxides are added to remove alkaline impurity. We don't add acidic oxide, we add basic oxide because calcium oxide is a basic oxide. Metal oxide can be a basic or amphoteric, but calcium oxide is a basic oxide. Coke is added as a reducing agent. We don't add coke here. We don't add carbon here. Oxygen is blown into oxidize the impure iron. Oxygen is not added to iron, oxygen is added to carbon. And steel produced contain less carbon than impure. That's true, because what happened when the oxygen is blown, the carbon react with oxygen, so carbon plus oxygen give carbon dioxide, CO2. And this carbon dioxide gas, the carbon will escape, and amount of the carbon in the impure iron or steel which is formed will be less, because the oxygen which we blow react with carbon to form carbon dioxide. So D is the right answer. In question 26, we have to identify the reactivity of the metal. Always remember, the more reactive metal displaces the less reactive metal ion. So if there is no reaction, it means ion is more stable. If there is a reaction, it means metal atom is more reactive. So here P, when we try, there is no reaction. It means Q is more reactive. Q, because there is no reaction, so P is not able to displace Q. So P is more reactive than Q is more reactive than P. Because when we try to react with them, P is not able to displace this Q. So it means Q is more reactive than P. Then when we check R with P, so R is able to displace this P. There's a reaction, so it means R is more reactive or R is above. Then we check Q with S. So Q is more reactive than S because Q is able to displace, so S is between them. When we check S with P, so S is able to displace, so it means S is more reactive than P. Then we check S with R, so S is able to displace this R, so it means S is more reactive than R, so S will be above R. And when we check S with Q, so S is not able to displace Q, it means S is less reactive than Q. So what is the order of the reactivity? Which is the most reactive? Q is more reactive than S, S is more reactive than R, and R is more reactive than P. So Q, S, R, P. So option C will be the right answer. So always remember, the more reactive metal displaces the less reactive metal ion from its solution. If there is no reaction, it means the metal ion is more reactive, or ion, the metal which is existing as an ion, is more reactive. If there is a reaction, then the metal atom is more reactive. Aluminium is extracted by electrolysis from which ore? What is the name given to the ore of aluminium? That is called bauxite. And at which electrode aluminium is deposited? Aluminium is a positive ion, and positive ions are always attracted towards cathode or negative electrode. So ore is bauxite, and aluminium will move towards the negative electrode because the positive ions are always attracted towards the negative electrode or cathode. In question 28, zinc oxide can be reacted with carbon to produce zinc metal. Which equation for this reaction is correct? So zinc oxide is reacting with carbon to produce zinc metal. And the equation must be balanced as well. So this equation is correct, but this equation does not appear to balance, because on the left hand side you have 2 zinc, 2 oxygen. On the right hand side you have 2 zinc and 1 oxygen. So this equation is not balanced. So it must be a balanced equation. When you check this, 2 zinc, 2 oxygen and 2 carbon. Here 2 zinc, 2 carbon, but how many oxygen are there? 2 multiplied by 2, 4. So that's why it is wrong. When we check this left hand side, one zinc, right hand side, one zinc, one oxygen, one carbon. So this equation is balanced with all the reagents. Here also one zinc, that is right, but one oxygen and 2 multiplied by 2, 4 oxygen. So this is not the balance. So we just simply have to check which equation is balanced, and according to the balance equation, we can work out that which reaction will occur. Air is a mixture of the gases. So which gas is present in the largest amount? So which gas we have? Nitrogen is there in the largest amount, the largest proportion of nitrogen is present in air. Then which information about the carbon dioxide and methane is correct? So form when vegetation decompose carbon dioxide, not carbon dioxide, methane is formed. So this option is not correct. Greenhouse gases, both are greenhouse gases, carbon dioxide and methane, both can contribute to global warming, or both are greenhouse gases. So B is the right answer. Present in unpolluted air, carbon dioxide is present. Methane proportion is not there. Produced during respiration, carbon dioxide is produced during respiration. So that's why the correct answer, as I already mentioned, B is the right answer, that both carbon dioxide and methane are the greenhouse gases which contribute to global warming. In question 31, underwater steel pipes can be protected from corrosion, from uh, rusting by attaching a magnesium block to them. Which equation represent the reaction that prevent the corrosion? So what happened? Like we have underground pipes, steel pipes are there. We place magnesium. Magnesium is more reactive than iron. So magnesium is more reactive than iron, so it will lose electron and electron transfer to iron surface. Because what is the tendency of the more reactive metal? Metal tend to lose electron, but more reactive metal tends to lose electron easily. And magnesium belongs to group 2, so it will lose 2 electrons. So which statement is correct? A and B cannot be an answer because iron is less reactive, it cannot lose its electron. So C or D can be an answer. In which one magnesium atom is losing electrons? So C, magnesium atom loses electron and turn into magnesium ion. Question 32. Ammonia is manufactured by a Haber's process and the reaction is exothermic. So when the reaction is exothermic, reactants have high energy and the product will have low energy. So N2 plus 3H2 gives 2NH3. So which statement about the Haber's process is correct? The reaction is irreversible. That is wrong. As you can see the arrows, the reactant can form a product, product can form back the reactant. So reactions is reversible. This is a reversible reaction and produces less ammonia at high pressure. If we increase the pressure where the balance or equilibrium shift towards side of less moles, so here 1 plus 3, total 4 moles of a gas and 2 moles of a gas. So when we increase the pressure, equilibrium or the balance shift towards the right hand side. So we'll get more ammonia, not less ammonia. So that's why B is wrong. The reaction is reversible and produce less ammonia at high temperature. That's true because it's a reversible reaction. So if we increase the temperature, product will start to decompose and form back the reactant. So percentage of the ammonia will start to decrease. So C is the right answer. The reaction is slow because the catalyst is not catalyst. When we use a catalyst here, the reactions are faster, and the reaction is slow because of a catalyst use. That is totally wrong because when we use a catalyst, catalyst alter the speed or the rate of reaction. Sulfuric acid is manufactured by a contact process. The most important reaction is in the presence of a catalyst, what are the reactant and catalyst used? So for a contact process, the reactant is the sulfur dioxide mixed with oxygen to form sulfur trioxide. These are the reactants, sulfur dioxide and oxygen. And what is a catalyst? Vanadium pentoxide or V2O5 is a catalyst. So sulfur dioxide and oxygen are the reactant and vanadium pentoxide is a catalyst. Iron is used as a catalyst for Haber's process in which nitrogen and hydrogen react to form ammonia gas. Which box correspond to limestone? Does the limestone contain carbon? What is the limestone? Limestone is calcium carbonate, CaCO3. Does it contain carbon? Yes, it contains carbon. Does the limestone burn? We don't burn limestone. Limestone can decompose to give calcium oxide and carbon dioxide, but it does not burn. We are not burning. It's not a fuel. That's why limestone cannot be burned. Petroleum is an important fossil fuel. Which row correctly describe petroleum? So what is a petroleum? Petroleum is actually a crude oil is a mixture of the hydrocarbon. It contains like petrol is there, naphtha, refinery gases, fuel oil, diesel, paraffin, or kerosene, or bitumen. These are different fractions, different compounds present in the petroleum or a crude oil. So crude oil is a mixture. And what it contained mainly hydrocarbons. So mainly hydrocarbons are present. Like hydrocarbon means compound which contain carbon and hydrogen. Not only like there are other substances, but mainly hydrocarbon. Most of them are hydrocarbon. So butane react as shown. Butane in the presence of catalyst form butene and hydrogen. What is the type of the reaction? When we break down a molecule, a hydrocarbon like butane, but means 4 carbon and ane means number of the hydrogen will be twice plus 2. So 4 multiplied by 2, 8 plus 2, 10. So C4H10. So it will turn into C4. Butene means H8 plus hydrogen. So when we break down the hydrocarbon into smaller fractions, what we call this process, we call this as cracking. Cracking means like breaking out the molecule. So B is the right answer. Combustion means burning. If we burn, then it should produce carbon dioxide and water. Polymerization means the small molecules form a long chain compound. We call that as polymerization. And reduction is either removal of oxygen or addition of hydrogen is called reduction. Question 37. Substance Z has the following characteristics. It burns in an excess of oxygen to produce carbon dioxide and water. So it gives an idea that it contains carbon and hydrogen. It oxidizes by air to form a liquid smelling vinegar. So alcohols can, when smelling vinegar, it means it turns into ethanoic acid. And ethanoic acid or how acids are formed by oxidation of alcohol. When alcohols are oxidized, it will produce acids, carboxylic acid. So it gives an idea that it is a fuel. It can be oxidized to form acid. So it means it's an alcohol. And it reacts with carboxylic acid to form esters. So esters are formed when alcohol react with carboxylic acid. So alcohol plus carboxylic acid, it will give ester plus water and the reaction is reversible. So what is the substance Z? So what is this substance Z? Substance Z is an alcohol. So which one is alcohol? This is not alcohol. So only option C is alcohol, which is ethanol. These are all the characteristic of alcohols. And because if it is vinegar, it means ethanoic acid. And ethanoic acid can be formed from ethanol. Ethanol is manufactured by catalysts catalytical addition of a steam to ethene and by fermentation. So there are two ways to produce this ethanol. Is one is by addition of steam in the presence of the phosphoric acid, and another one is fermentation, in which the glucose produces in the absence of oxygen in the presence of yeast. So enzymes, the biological catalyst, will speed up this reaction and convert the glucose into alcohol. So which row shows an advantage and disadvantage of using catalytical addition of steam compared to that of preparing by fermentation? So what are the advantages here? Because this reaction, the advantage is catalytical addition is fast, but the disadvantage is that, like, it is using non-renewable resources. Like, a time will come when we'll run out of these sources, so it used non-renewable resources. Ethene is there, so B is the right answer, that the reaction is fast but uses the non-renewable materials, the material which cannot be used up again, or limited supply is there. The partial structure of addition polymer X is shown. So this is the addition polymer. Polymerization means when a small molecule form a long chain compound, we call polymerization. So how to work out the formula of the monomer? Monomer means how to work out the small molecule. Which monomer is used? So the simple way to identify the monomer, just take first two carbon atoms. So we'll take first two carbon atoms. And the monomer in addition polymer, they should have a double bond, so there will be a double bond here. So 1, 2, 3, 4 carbon. So there will be 4 carbon atoms, 1, 2, 3, 4 carbon atom. Between second and third carbon, there's a double bond. And there is H attached. This is the first 1, 2, 3, 4 carbon, as you can see here. So first carbon is having 3 hydrogen, second carbon is having only 1 hydrogen, third carbon is having 1 hydrogen, and the fourth carbon is having 3 hydrogen. So this will be the monomer, this will be the molecule which joined to form this long chain compound. So what is the monomer for this polymer X? So it should be 4 carbon atoms. So which option is having 4 carbon atoms, C or D? But the double bond between the second and third, so double bond between the second and third, that's why C is the right answer. So whenever we want to work out the monomer, this is always the way that you will select the first 2 carbon atoms, take out the structure of first 2 from the addition polymer, and just make a double bond between the 2 carbon atoms. And so 1, 2, 3, 4 carbon atoms are there, and second and third have a double bond. That's why C is the right answer. The diagram shows the partial structure of phthalate. So how phthalate is formed when dicarboxylic acid, like 2-carboxylic acid, react with diol, 2 alcohol groups. So one compound, both sides should be carboxylic, another one, both sides should be alcohol. So which one? As you can see, this is C double bonded with O and OH, C double bonded with O and OH. So this is dicarboxylic. Di means 2, and carboxylic acid because of C double bonded with O and OH. And this one is OH is there, so this is diol. So when dicarboxylic acid react with diol, as a result, it will produce polyester or hyaline. So A is the right answer. Why not B? B is not a dicarboxylic acid. One side carboxylic group is there, one side OH. So that's why it cannot be. This one is diol and this is dicarboxylic acid. But as you can see, it is not shown correctly. The shaded part is with OH. And the unshaded part, the box is with C double bonded with O. Here, so if, as you can see in the structure, with C double bonded with O, the box is there. But here with the structure C double bonded with O, the shaded box is there. That's why this is not the right way. And the last one, as you can see, both are carboxylic acid, so it won't form a polymer. So this was the paper October, November 2016, paper 2, variant 1.